Welcome to Ask and Learn.
So they want us to assume that S with this ordering and T with this second ordering are posets. And now they want us to show that so the Cartesian product with S and T with this ordering where ST is less than or equal to UV if and only if S is less than or equal to U with the first ordering and T is less than or equal to V with the second ordering. So we want to show that this is a poset. All right, so let's go ahead and start our proof. So first, let's get all of our assumptions out of the way. So assume that S with this first ordering and T with this second ordering are posets. Now we will, so for S cross T, define our ordering here to be ST less than or equal to UV if and only if S with the first ordering is less than U and T, the second ordering, is less than U. Less than V. All right, so now that we have all of our assumptions out of the way and we've defined what this ordering should be, we want to show that S cross T with this, so for something to be a poset, it needs to be 1, reflexive, 2, anti-symmetric, and 3, transitive. All right, so let's go ahead and start with reflexive. So 1, reflexive. All right, so we want to assume that little s t, so assume little st is an element of S cross T. Well, by the definition of the Cartesian product, this implies that S is an element of capital S and T is an element of capital T. And due to S with this first ordering and T with this second ordering are posets, they are reflexive, which implies that S with the first ordering is going to be less than or equal to itself, and T with the second ordering is going to be less than or equal to itself. And now this implies, by definition, that S of T is less than or equal to itself by definition of just our ordering, right? So we've shown it is reflexive. So S cross T with this ordering is reflexive. All right, now the second thing we should show is that it is anti-symmetric. So 2, anti-symmetric. So now remember, anti-symmetric means, so I'll just write this up here. So if x is less than or equal to y, then y is less than or equal to x only if x is equal to y. So we don't need to write this, but let's just go ahead and keep this right here for while we're solving it, just to kind of remember what it means. All right, so we want to assume that ST, UV, are elements of S cross T. All right. And also on top of that assumption, we want that S of T to be less than or equal to UV. Okay. Well, what this would tell us is by definition, so by definition of our ordering, this implies that S is going to be less than or equal to U with respect to that first ordering, and T is going to be less than or equal to V with that second ordering. And we know that this will only be the case since S and T are posets if they are equal. So we know since S with the first ordering and T with that second ordering are posets, that U less than or equal to 1S and V less than or equal to T with that second ordering only if U is equal to S and T is equal to S. Thus, this implies that S, or actually UV with our ordering here will be less than or equal to ST only if UV is equal to ST. So, thus, S cross T with this ordering is anti-symmetric. And now the last thing we want to show is that it is transitive. So let's just kind of write what that means up here. So if we had x less than or equal to y and y less than or equal to z, then this implies that x is less than or equal to z. So we want to show that. All right, so so I'm actually going to use ax, by, and cz, and we're going to say that all of these be in S cross T. And we want these such that AX is less than or equal to BY and BY is less than or equal to CZ. All right, well, I'm going to call this statement 1 and this statement 2. Well, statement 1 implies, so by definition of our ordering, A is going to be less than or equal to B with that first ordering, and X is going to be less than or equal to Y with that second ordering. Now the second one implies, also by the definition of our ordering, that B is less than or equal to C and with the first order, and Y is less than or equal to Z with that second ordering. Now, this here implies, since A capital, not A, S. So S with this first ordering and t with this second ordering are posets. They are transitive themselves. So actually what I'm going to do instead, let's not do this, but due to this here, so I'll just at least circle this in red. So due to this here, that is going to imply that A is going to be less than or equal to C with that first ordering. And then this is going to imply that X is less than or equal to Z with that second ordering. Now, this, by the definition of our ordering, implies that A, X, is going to be less than or equal to C, Z. So thus, S cross T with this ordering is transitive. And so let's just make sure we've shown everything. So we've shown it's reflexive, we've shown it's antisymmetric, and we also shown that it's transitive. So now we can go ahead and say, since S cross T with that ordering is reflexive, transitive, and antisymmetric, it is a poset. Then we can put our little proof box and a smiley face because we're glad we're done with the proof.